So, in order to explain how an ion forms, consider a neutrally charged atom. Remember, the number of protons and electrons are equal. The overall charge of the atom is zero, the net charge. The valence number, or the number of valence electrons for an atom, can be found using the periodic table. So, to obey the octet rule, atoms tend to use the easiest possible route, which means atoms with a valence number of 1, 2, or 3, meaning 1, 2, or 3 valence electrons, it's easier to lose a few electrons to complete the octet rule. It's easier to get rid of one single electron than it is to pick up 7. It's easier to get rid of 3 than it is to pick up 5. An important thing to note, an atom that loses electrons still has the same number of protons in the nucleus. But it now has more positively charged protons than negatively charged electrons. So remember what we wrote earlier, and you're going to see this a bunch of times. Net charge equals number of protons minus number of electrons. So there are more protons than electrons, which means it's going to be positive. The charge of the ion is now positive. Any ion with a positive charge, and this is just a very general term for any positive ion, the pronunciation here is cation. So we're talking about ions. It is cation. So what we find is that most cations are metals. Metals tend to be towards the left side of the periodic table, tend to have 1, 2, or 3 valence electrons. And they also tend to be towards the bottom of the periodic table. We can predict the charge of cations. We can predict the charge of cations of the main group elements just by looking at the periodic table. So elements in group 1. This is something that came up in Unit 3 and Unit 4. Elements in group 1 have 1 valence electron. And this is true for all of the group 1 elements. Elements in this group end up losing 1 electron. So let's pick one. Let's talk about potassium. Potassium is a group 1 element. Here it is. It has 1 valence electron. Elements in this group tend to lose 1 electron and form a cation. So here it is, neutrally charged potassium. It's very unstable. When you open the container, it tends to just explode. And that is potassium's attempt to make itself more stable. That little explosion, well, little is not the right word, that big explosion coming out of the jar when you open the lid is this electron trying to get away. Because it doesn't want to be there. It's too far away from the nucleus. It wants to go somewhere else. And so this is the more stable version. So what we have is, so let's talk about net charge again. Remember, it was the number of protons, which is 19, minus the number of electrons. Elements in this group tend to lose 1 electron. And so it had 19, it lost 1, now it has 18. And so the charge here is positive 1. Positive 1 right here. So elements in this group lose 1 and they form a cation with a plus 1 charge. Elements in group 2 each have 2 valence electrons. So let's pick one. Let's look at magnesium, Mg. So here's an electron, here's an electron. There is its 2 valence electrons. So magnesium is not nearly as reactive as potassium or the other things in group 1. Group 2 is a little different, not as reactive, and that's where magnesium stays. So magnesium will, in some circumstances, get rid of these 2 valence electrons. So they will lose both of those electrons because it wants the complete octet. It is easier to get rid of these 2 than it is to find 6 others. So it's going to lose 2 electrons. And so here's our net charge. Net charge, it has 12 protons, and it's going to lose 2 electrons, which means it's only got 10. And so 12 minus 10 tells us the net charge is plus 2. So we're looking at something like this happening. Mg and the superscript. Now the charge is positive 2, but it's commonplace to write Mg2 plus. The number comes first and then the sign comes second. So again, that's another one of these things where this is your chemistry classroom, your math classroom is down the hall. Keep chemistry in chemistry, keep math in math. Number comes before a sign. So then we have elements in group 3 through 12. If you're looking at the periodic table, this is that big block in the middle. So elements in groups 3 through 12, they form cations, but the charges of the elements vary, and it's difficult to predict using just the periodic table. So these elements are given a name. It's transition metals. It gives this the name because the charges can change. And transition means changing. Transition metals, they're complex. They don't tend to follow a trend when forming ions. Remember, even the electron configurations we didn't work with in this class. And that's because they're complex. They kind of go out of order sometimes. And then they end up making different charges. But when necessary, we can generally figure out the charge of these elements using other clues. And we'll talk about that later in the unit. Then there's elements in group 13. Remember I told you for groups 13 through 18, the valence electrons was the group number minus 10. So elements in group 13 each have 3 valence electrons. So elements in this group are going to lose 3 electrons because, again, it's easier to lose 3 electrons than it is to pick up 5. So if we were talking about, let's say, aluminum, so here's my aluminum atom and it's neutral. These 3 electrons might be taken away by other atoms. So what we end up with is an aluminum ion with a 3 plus charge. And again, looking at in terms of net charge, it has 13 protons. That's always the same. But then it lost 3 electrons. Net charge is 13 minus 10, and that is positive 3. So they tend to lose all 3 of these valence electrons and form ions with a plus 3 charge. So example 3, I've basically been doing this as we go along rather than just put them at the end. I'll write this in quickly. So we talked about sodium. We have in the past 11 protons, 11 electrons when it's neutral. Looks something like this. It's in group 1, has 1 valence electron, it's going to lose it. Net charge is now 11 protons minus 10 electrons, and that's plus 1. Gives us that positive 1 sodium ion. Calcium, so we have 20 protons, 20 electrons when it's neutral. 2 valence electrons, which means it's going to lose 2. Net charge 20 minus, now it only has 18, positive 2, and the calcium ion is 2 plus. And then aluminum, which we already did. Aluminum has 13 protons. When it's neutral, 13 electrons. It's going to lose 3. Lose 3. Net charge, we have 13 minus 10, and that is plus 3, giving us that aluminum 3 plus ion.